Good morning, everyone. Welcome to today's webinar, Reinvent Your Legacy Software Ecosystem with AI-Driven Modernization. I'm Revati Kumar, your host for this session. Thank you all for joining us today. We're really excited to have you all here. Today's session, it focuses on how enterprises can modernize strategically, reduce technical debt, and unlock long-term value using AI-led approaches. So, before we begin, a quick note. The session will run for approximately 30 to 45 minutes. Please feel free to post your questions anytime in the chat. We'll address all the questions via email by consulting subject matter experts. Here's what we'll cover today. Why legacy modernization needs a new AI-driven approach. How AI accelerates application assessment, refactoring, and optimization. Practical strategies to modernize without disrupting operations. And real-world scenarios and outcomes from AI-led modernization initiatives. Now, it's my pleasure to introduce our speaker, Manish Verma. Welcome, Manish. Thank you so much for being here. Over to you.
Thank you, Revati. Thank you very much for the introduction. Um, hello, hello everyone. Let me share my presentation and then I will get started from there. Is it visible, my presentation?
Yes, it is.
Okay. All right. Good morning, good afternoon, everyone. Thank you so much for joining us today. I'm really excited about this session because we are going to talk about something that I know keeps many of us up at night. Those legacy systems that are running your business, right? Before we dive in, let me ask you a question and be honest with yourself here. How many of you have system in production right now that were built when the flip phone or feature phone were the cool device? Uh, it's quite some time, right? System where the original developers have long since moved on, and every time someone has to make a change, the whole team holds their breath. Yeah, I thought, right? It's right. All right. We all think the same. So you are not alone. In fact, in, in a recent Gartner study found that over 80% of enterprise IT budgets are locked up maintaining these aging systems. But here's the exciting part. We are living in a moment where artificial intelligence has fundamentally changed what is possible when it comes to modernizing these systems. Today, I'm going to show you how we are helping organizations break free from legacy constraints, not in years, but in weeks. So let's get started. Here our roadmap for today. So here is our roadmap for today. We are going to cover 4 key areas. First, we will talk about the legacy challenges. And I'm not just going to throw some statistics, numbers to you here. I will share some real stories from the trenches about why these systems become such a burden. Why these systems are such a burden. Then we will dive into AI powered modernization. This is where things get really interesting. This is where things get really interesting because I will show you how AI isn't just a buzzword here. It is a genuine game changer that's cutting modernization timeline into half using modernization tools. Next, we will look at practical approaches because there is no one size fits all solution, right? Whether you are dealing with some 30-year COBOL system or some 10 years old Java monolith stack based system, we will discuss what approach makes sense. All right. And finally, we will talk about building resilient systems because the goal isn't just to modernize, it's to build something that won't become tomorrow legacy nightmare, right? Okay. I will also share a real case study of a project we have recently completed at transforming a complex cricket management platform. So cricket is a game where most in India it's been played and across the globe it's been played. So cricket is a very exciting game, and we have this solution complex solution built, which is a cricket management platform solution using Java uh, and how it can modernize to React and Node.js or Microsoft tech stacks, and how we have done this project. Some of the results might surprise you when I will share some of the facts and figures. All right. All right. So let's start by acknowledging the elephant in the room, the legacy system. Okay. So take a look to these numbers. So if you look at 70% of IT budgets spent just on maintenance and 300 billion, that's billion with B, in annual tech debt costs globally. So these are some staggering numbers which really stands out here about the legacy system. But let me make this real for you with a story. So I was talking to a CTO last month, a mid-sized financial service company, about 1,000 to 1,500 employees. And what she told me about their core transaction processing system, it was built somewhere in 2008 or 2010 timeframe, and it runs on Java 6. And here is the kicker. The last person who truly understood the code base, I think, retired some 3 or 4 years back. So every time they need to add new features, something as simple as supporting a new payment type, it usually takes them 3 or 4 months, not just because feature is complex, but because they are terrified of breaking something. They have made what they have made. Okay. They have what she's called archaeology sprint, where developers spend weeks just trying to understand what the existing code does. And their security team, they are having nightmares, like the system is running on unsupported version of Java and with certain known vulnerabilities, but they cannot upgrade because nobody knows what it will break. So look at this slide, main common pain points. Look at these common pain points. The outdated technologies, we are talking Java 6, COBOL, Classic, ASP, technologies where finding developers is like finding a needle in a haystack. And then we have a monolith architecture. So everything is interconnected. As we know in monolith architecture, touch one thing and you might break something on the other side of the application. Tribal knowledge, the documentation, if at all it exists, It is outdated. The real knowledge lies in the hands of people who may not be around anymore. But here is what really costs money. It's not the maintenance itself, it's the opportunity cost. While your competitors are shipping new features weekly, you are stuck with maintenance mode. While they are leveraging AI and modern analytics, you are struggling to integrate anything new. That's like 3x or 5x slower time to market. That's not just an inconvenience, that is market share slipping away. All right. So, what is changed? Why we are talking about this now? The answer is artificial intelligence, and not the way you might think it is. Let me be clear about what AI driven modernization actually means, because there are a lot of hype out there about AI driven approaches. You can read the code there, uh, written there about the AI modernization. So this is about some magical tool, and this isn't about some magical tool, sorry, that reads your COBOL code and spits out some perfect React or some other tech stack coding language. No, it's not about that. That sounds like a science fiction, right? It's something getting input and you're getting a baked output. What AI actually does is act as a incredibly powerful assistant to skilled developers. So let me give you one concrete example. Last year, we worked with one healthcare company, and they had this patient management system. And this patient management system is around 150,000 lines of Java code, hundreds of database tables, and almost no documentation. So in the past, before we had these AI tools, the first phase would be to be what we call discovery, right? A team of architects would spend, let's say, 5 to 6 weeks manually reading through code, drawings, drawing diagrams. They would uh, take out the diagrams from the code, mapping dependency. It's tedious and it is very error prone work. So with AI, we feed that code base into a AI analysis tool. And within 48 hours, not in weeks, in hours, we had a complete dependency map, documentation generated for every service of a function, and identification of dead code and redundant patterns. A race assessment of which module were most fragile. So all this output we get within 48 hours, not in weeks or multiple weeks, you can get in few hours. So here I want to say the AI doesn't replace the architects. They still need to validate and make decisions, right? But instead of spending weeks gathering information, they spend that time actually analyzing and planning of these results, what AI assisted tools has given. So this is what I mean by intelligent analysis, accelerated development, and quality assurance. AI handles the grunt of work at superhuman speed, freeing humans to do what humans do best, make strategic decisions. All right. So let's walk through how AI impacts each phase of modernization. You can look at the top, those circles, 1 to 5, and first one, right? That is discovery. So I have mentioned this in the previous slides. AI can analyze million lines of codes overnight. It can identify patterns, flags potential issues, and creates documentation that would take humans months to produce. So that is typically about the discovery phase manner. Then the planning. So this is where it really get exciting. AI can actually helps recommend architecture patterns based on your specific code base. It has seen thousands of modernization patterns and can suggest, based on your code structure, here is what other successful projects have done. So LLM models have their own base knowledge where they can actually extract out the best pattern for your code and particular code structure. Uh, the next one is nothing but the development. And here where we see the biggest gain, right, in the development. And look at this comparison table below down there. So if you look at this whole table and the comparison between the traditional approach and AI assisted approach and certain tasks. So look at this traditional API development, right? 4 hours it would take in traditional approach to develop one endpoint, API endpoint. Why, if you apply AI assisted approach, you can actually do it in 10 to 15 minutes each uh, API endpoints, like contract signing, like contract API contract signed, and that's kind of development what we do in Agile. Here with AI assistant tool, you can do in 10, 15 minutes. And that's not the typo. It is actually you can get in 10 to 15 minutes using AI assistant tools. So when a developer is working on AI coding, assistants like, so they get help from something like, these tools available. I'm pretty sure you would have heard about GitHub Copilot, Code, CLI. They can, so when they use this kind of tool, they can describe what they need in natural language. They can just like English, like statements, what they need, and they can get the work implemented. So it is like prompting. Uh, Most of us knows, right? Is in today's time how natural language prompting we can do and give certain context and get the implementation done, and then basically refine it and move on to next task kind of. So let me share a very specific example here. Okay, in our cricket platform project, this is a cricket social, which is an in-house we have developed over a period of time. We need to build. Um, so when we got this project, what was needed was to build a real-time scoring system. So what has happened is the developer describes what they need. So real-time scoring system, they can define a certain context of what they need. And like, I need a, let's say, they say in very plain English like context, like I need a WebSocket based scoring system that handles ball by ball updates and maintains match states and broadcast score to connected clients. So such prompt and context, given what we saw, that within 20 minutes they had a working implementation, and not just the boilerplate code, but with the actual business logic, with error handling mechanisms, the validation, the test, the unit tests, and functional spec and functional documentation around that logic getting implemented. And then if you look at traditional approach, this would have taken pretty much at least couple of days or maybe almost a 1 week sprint to implement. All right, so that's about development using Copilot, GitHub Copilot or Cloud Code, CLI, such AI assistant tool in the time of development. And then next one is testing. So about testing, this is often, treated like a neglected stepchild of development, right? We know in software engineering, like it is needed, but sometimes you park it um, and do it later kind of thing, or maybe implement even when the whole module is being getting developed, because probably you have a pressure of going through a sprint cycle and things like that. And because of that, sometimes the unit testing and test cases getting skipped. But with the AI assistance and with the AI tool, actually test cases and test suites for that particular code base or particular function or particular module. Actually, it is get generated along with the code side, along with the code. Not just the basic tests, but complete comprehensive test suite covering even the edge cases. So in a traditional project, testing is often is like, oh, okay, we'll do it later. We have a lot of pressure to deliver certain modules. And then that later never comes, right? But with AI assistance, you can do this with the assistance of uh, AI development tools uh, at the time of coding itself. Okay, the last one is nothing but documentation. All right. So here is a little kind of dirty secret about software industry. Documentation is almost always outdated by the time it is written, something like that, right? So with AI and AI assistant tool, using of that in a project, yeah, you can get documentation is generated at the time of code development itself when you're developing code with the tools. Isn't that kind of very good thing to have? Or maybe not, but it is incredibly practical, right? You want to have a documentation when you're developing a code. Absolutely. All right. Let me go to the next slide. Okay, now let's talk strategies, right? Because the biggest mistake I see an organization makes is jumping into modernization without a clear approach. So let's see what strategies we can adopt. All right. So not every legacy system needs the same treatment, right? Let's walk let me walk you through your options here. So what are the options uh, for the modernization path, right? Basically what kind of strategies you can have. Uh, First one is replatform. So what is replatform? It's basically a low risk, right? So this is your low risk option. You are essentially what you're doing here, taking your existing application and moving into a more modern infrastructure, right? So replatforming is like you're moving into a cloud or containers, Docker containers, without changing actually the code significantly. It's more like on going on the platform level changes, more on the modern infrastructure, moving into more modern infrastructure. So I would like to take some example around this. And the real example, uh, so there was a client, it was running like a .NET application, I would say like on-premise Windows service, and the application itself is fine. Like there was no problem with the application, but the problem was, but they have spending a fortune on hardware maintenance and could not scale the peak load periods, so they could not able to uh, you know uh, basically change the hardware for their peak load time. So basically they could not able to scale the system. So we could able to recognize this and move it to, like suggested, to move that into Azure Kubernetes service. And this kind of changes with the help of AI assistance, infrastructure structure cost actually came down by 40%, because as you know, with Azure Kubernetes services, you can you can gain basically auto scaling capabilities. So this code was barely changed in this example, but operational benefits were quite big. So when to choose this particular, you know, strategy, when you want to refactor, you don't want to refactor, basically you want to re-platform it, then you choose when your code is basically maintainable. You just need to do a better infrastructure. The next strategy is the refactor. So this is about improving the internal structure without changing external behavior of your system. So breaking a monolith into services, improving code quality and adding proper patterns. So that is more like refactoring. Uh, the next one is primarily is like almost like a high effort driven approach, where you basically rewrite. So what is rewrite? Typically rewrite is nothing but it's a nuclear operation, or it's a nuclear option. You are building everything from scratch into a modern technology. So this is always seen as a risky, and it can be. So what AI can do here, AI reduces the rewrite time by 50 to 70%. What we used to do in multiple months or maybe more than a year with risky approaches, now you can do it in months time, rewriting with the AI assistance tools, where you can rewrite the whole system with the assistance, with the reliability, and it can reduce your time to rewrite probably with 50 to 70%. Um, the last one is most interesting and the most recommended one, the strangler pattern. This is my personal favorite kind of. And this is primarily done for large critical systems. So here you can build new features in a modern systems while gradually migrating functionality from old system. The legacy system shrinks over time until they can be retired and new system can come in. So this is about the strategies. Let me go to next slide. All right. So let's talk about where where you are going, or not just where you are, right? So look at this diagram, the top diagram. So if you look at from left to right, so legacy to AI powered transformation to modern tech stack, right? So this isn't just swapping technology. It is not like just you swap, like, right? It's about fundamentally changing how your software operates. Okay, so these are the technologies we typically modernize. You can look at the modern technologies below in the below boxes. So first one, like as I've given you an example, like you have a JSP, MVC, pattern driven older framework or Java 6 based implementation. You can move to new technologies like React and Next.js for the front end, which is more like a component based architecture. They are pretty fast. Then you can also move your backend to Node.js or Express.js um, to implement the backend JavaScript is everywhere. So it is very good for the APIs, excellent API, real-time for application API, real-time applications. I'm typically not touching too much here in a Microsoft tech stack yet, but that can also can be incorporated. Tech stack become which one you want to adopt to. And typically TypeScript here, because TypeScript safety catches your bugs before the production. Databases, uh, can move to any preferred database, maybe a Postgres, MongoDB, SQL Server, or MySQL, depending on your data needs. Then Docker or Kubernetes for consistent deployment and scaling, like you can have serverless approaches, Lambdas, Fargate in AWS, and on Azure cloud like Azure Functions, more like serverless, which can make your system, when you modernize, because of the serverless nature, uh, pay for what you use kind of behavior. And then Terraform is basically on the infrastructure level. Um, Infrastructure as a code, you can have a Terraform, so your environment are basically reproducible. So I basically want to pause here for a second. Um, just give me one moment. I'll just have a little water, if you don't mind. So here the goal isn't just some latest shiny technology we want to use. It's about building a foundation that will serve your next for a next decade. So you're moving from legacy system to modern system, but want to make sure in the AI assistance, when you move to legacy to modern, you are serving your system for next couple of decades. So you take care of that um, while you're modernizing your tech stack. Okay, uh, this slide. Um, let's talk about what you actually get when you modernize, right? The tangible benefits that justifies the investment. Okay. So here are three pillars I want to focus on: the scalability, the security, and performance. So let's talk about scalability. So let me take one example about scalability. So there was a one client, and this was like a known story. They have their legacy system crashing during their biggest sales uh, in a certain time period, where they were losing uh, their revenue in millions in a couple of hours or in a day, because that system simply could not handle the traffic peaks. And when they went for the modernization and they could able to apply modernization techniques, they could able to change their legacy system into modern system, what I previously covered in slides, and they could able to overcome the bottlenecks what they faced in the traffic spikes what they used to experience, because they have used the modernization techniques and the AI assistance tools to overcome this hiccup, where they have become auto scaling systems, where they can add the capability automatically to scale up and scale down based on their traffics, and they need not to even monitor that system closely when they do this approach of modernization from a legacy to modern system. Okay. Uh, so scalability, I was talking about one of this example. Second one here is about security. So this particular security feature I just want to take example of same, like there is a financial service CTO I was talking a couple of months back, uh, an earlier example, and their biggest fear wasn't about the performance. It was about data breach. So their legacy system was running probably on a framework which is like a common vulnerability exposure, something terms called CVSs, right? So every security audit was a nightmare for them. With the modern system, when they upgraded and modernized the system with the AI assistance, they could upgrade their systems such a way that they could able to apply regular security patches, and which actually help them to reduce their vulnerability issues on the real system. And when they modernize also on the security with certain aspects of authentication mechanism with like using OAuth or JWT, they could able to achieve better security, end-to-end security. And they can also able to apply in security in modern systems when they migrate uh, like encryption technologies where they can encrypt their data. And on the security, like automated vulnerability scan could be a part of CI/CD pipelines. So when you are applying this CI/CD pipeline in a modern systems, they always comes with an automated vulnerability scan mechanism. All right. So uh, I would like to talk something about performance. So after modernization with proper caching mechanism, optimization of queries, modern front-end framework usage, they can basically their average load, what modern systems can bring it down. So I will take one user story here where um, on the legacy systems, there was a page load time was somewhere around 8 seconds on one of the systems. And basically this performance was hitting so bad for this particular customer that with their legacy systems, every page load they were losing customer. It is bleeding customer because customer could not get the page load operation properly, and they were getting frustrated and they were losing basically their customer base. Um, by applying performance optimization in terms of CDN approaches, caching mechanism with the modern technologies, they could able to bring down the page load operation average loading time around 400 millisecond or 600 millisecond within less than a second. And that's how their customer retention rate has dropped down what it was when they were losing customers. So if you look at in a nutshell, the below figure here, the bottom one. So what we can achieve with modernization is 60% like fast page loads, 40% cost reduction, and let's say 5 nines like 999, 99.99 uptime, and 3x faster deployments. So these are the operational right numbers which everybody want to achieve, and we can actually achieve this with modernization techniques using AI assistance. Right. All right, we'll go to the slide where we want to talk. So let me pull the curtain back and show you exactly how we do this. Okay, uh, because we are using this assistance tools in our day-to-day projects here. All right, so we practice what we preach here, I want to say. So every developer in our team uses AI assisted tool on a daily basis, and it's just not like an experimental thing. It's how we work, right? Uh, Typically, like the assistant tool, which is most top notch at this time frame is like a GitHub Copilot and Cloud Code CLI. These are our primary AI assistant tools we use, which it's not just like you are auto completing something. It's a generally thinking partner, right? Our developers have a conversation with it about architecture, ask it about implement features, and have their code reviewed through these AI tools and technologies. So let me give you a real example here, what we have done recently for with our Cricut platform project, which I've also talked about in previous slides. So one typical example, which was recently has happened in our project. So there was a developer who need to implement a complex scoring algorithm, right? Like in a cricket, you know that calculating batting averages, strike rates, bowling economy, or tons of other cricket statistics, right? So in this cricket game, the rules for these calculation have edge cases. You won't believe those edge cases, right? They are very uh, like a borderline cases. So what has happened, this particular developer describes the requirement and in GitHub Copilot or Cloud Code CLI, these AI assistant tool, and include all those edge cases as a in a prompt when they give input to these AI assistant tool. And within a couple of hours, they had a complete implementation, almost like a boilerplate code implemented with 40 plus around unit test cases covering each scenarios. And then when this has happened, basically in our project, this is reviewed by a senior developer and who could make some tweaks and changes, and it was done. So traditionally, this kind of task would have taken at least whole 1 week sprint. It was done in a couple of hours. All right. So that was I was talking about GitHub Copilot and Cloud Code CLI as a system tools, the most industry top notch at this point with LM model like Opus 4.5 and others being used. Let's talk about uh, Intel code analysis. Okay, so when we started actually modernizing this project, AI analyzes the entire code, legacy code base. We could able to give the complete code base as an input to this analysis tooling framework of GitHub Copilot and Cloud Code CLI. And when we have given this it to start the modernization project, AI analysis AI has analyzed the entire legacy code base. And what we got as output is we got the dependency maps, identifying the riskiest module, like where like this particular scoring logic, how complex it could be, and how you can achieve the real-time scoring logic. All those recommendations actually came from AI assistance. And it has also given us the complete data flow. And this used to take at least architect weeks of time, um, which could be done in few hours. Now let's talk about automated testing. So typically these tools helps you to generate test cases alongside with the code. Okay, and it's not like an afterthought. It happens there and there. And this is a very crucial because modernization without comprehensive testing is just like creating another legacy, right? Legacy system kind of thing. And lastly, the smart documentation. So in this project, every API endpoint, when it got converted from the legacy, like JSP framework and um, Spring MVC endpoints, those API endpoints and every function, every data model got documented automatically, and it was kept in sync with the code. The current code which got changed had the latest documentation along with that for each functions and each API endpoints. So if you look at the right hand side, what we got is productivity multiplier here, which is just so amazing. So look at these numbers, right? What we got is 6x faster API development, somewhere like 8x faster boilerplate code generation, where you get a base code to work on, further implement and fine tune. There also you'll get assistance from these tools, right? So it's almost like a development and boilerplate code or base code getting it to you extremely fast, where you can work on further to enhance it. And there also you can get help. So it become more faster. It's like 8x and then further you can multiply. So it's very fast. And then 4x for the UI component. So your UI component actually get directly converted. Your assets and everything can be reutilized. Even if you moving from a legacy stack to new stack, maybe React or whichever stack, or um, you want to write your UI components, it just gives you speed of around 4x or 5x. So if you look at the green box, what we got, the result, right? Result is like 2x or 3x faster overall delivery. So if you look at the whole sprint cycles to achieve the final implementation of whole project, you can go for a very high quality code, uh, maintaining very high quality code and not cutting any corners because you're getting all the test case and covered all the corner cases. And genuinely you are getting a better output with less time. All right. Uh, so what would be the approaches, right? Let me walk you through these approaches. Um, let me walk you through the 4 phases approach here. So phase 1 is assess and discover. I think this is where actually AI really shines. Uh, we run your whole code base, through our code analysis tool with this AI assistance, and within few days have a comprehensive understanding of like what is the technical depth at hotspot. It can depth hotspot, like what kind of depth, technical depth you have. That kind of output we we can get quite fast in the assess and discovery phase, and which modules are critical versus which can you can retire, in a sense like you can really retire and rewrite. In a rewrite approach, it can give you a code base which can be better, like you are changing some algorithm which is written in a such a fashion which is taking a lot of processing and uh, a time duration. So you can typically, if you get the logic out, you can typically implement that uh, with a new logic and retire that code altogether. So this kind of output you get in assess and discovery phase. Uh, what are the integration points? It can even give you in discovery phase and assessment phase what kind of integration point and dependencies you may have in the project, or in a project or in a module, and the whichever way you actually prompt the system, right? Uh, and what risk profile or different migration approach it can even provide you, that like how you can even database migration, uh, like we had this Cassandra DB, and if you want to move to Postgres DB, how this mapping and database table can, migration approach, it can suggest you. Um, so what all we do here, when we do actually assess and assessment and discovery phase. So basically we talk to your team kind of situation. Like we are not doing anything in isolation, right? Because there is a one term called subject matter expertise, right? So basically AI gives you technical picture, But then you have a subject matter experts who understand. I'm just taking one of the example here, like which is your people, like you know the subject matter expertise or that business logic, right, or business context, which features actually uses that business context. So um, we basically take that subject matter expertise while doing a discovery and assessment, and understand what are your pain points as a subject matter expert, so we can actually incorporate those in our prompts to get better, you know, results in this phase itself. So the next phase is the design and plan. So based on discovery, we create phased roadmap, and we identify quick wins, like what can we can develop very quickly, which we can show you as a uh, as an output, and what things we can modernize fast, that will demonstrate values, right, we can do in design and planning phase. um, and then we establish the success metrics, like we know if it will we will be on track for such implementation. So here are some key points. uh, we basically break the project into 2 or 4 week sprint with the tangible deliverables. You see the progress constantly and not just in the end. So we do this phase wise, uh, certain weeks of sprint with certain tangible delivery, uh, right, in the design and plan phase. Then next one, the third one is transform and build. So this is where AI accelerated development happens, where you do a transform and build. We are transforming, right, for the legacy to new systems. We build modern code, write test cases with the help of course, AI assistant tool. We can set up initial CI/CD pipelines pretty quickly, and also in an overall system, how it can get containerized, the whole application, that uh, that base knowledge also we actually do it in this phase. But critically, we are going doing this knowledge transfer throughout. So when your team is involved, we are actually making all the documentation, necessary documentation, and doing a knowledge transfer throughout this phase. So if we are working with your team, we are just not you are just not watching, but we are giving you learning new, how we are documenting it, how we are implementing new patterns, new tools, and this new way of working. We always share this with you too. And the last one is nothing but operate and optimize. So this is the last phase where, for any customer is like, okay, everything is done, go live. And then go live isn't just the end. What we do here in operate and optimize, we set up monitoring, optimize performance based on real-time usage of patterns, provide ongoing support. And we make sure that your team is fully capable of maintaining and evolving the system independently. So we do training, documentation, help, and sharing of that knowledge, everything. Next one. All right, we come to the almost in the end. One moment. Yep, this is the last slide. Uh, so let me bring all this together now. This is the last slide where I want to talk about, let's bring all this together in a real-time case study. So we have done this social cricket social platform modernization, which I talked about in previous slides. And you can look at these cards, right? The left-hand side and these four. So this was typically a cricket management platform. So if you take this case study, um, this project which we did, uh, this is a cricket management platform. This was on cricket management platform. It was comprehensive. So this cricket management platform was a comprehensive system that used by cricket boards, used to manage everything like tournaments, teams, matches, live scores. I've taken some example previously, and player statistics with the boundary conditions implementation, and some of the social features like publishing the scores to social media platforms. So what has happened in this particular use case I want to talk about is legacy system was built um, many years back. It was built on Java 8 with Spring MVC, and it was having somewhere around 280 GSP pages, and it's having the old DB technology like uh, DB, and it was mainly was deployed on-premise kind of deployment on AWS approaches, but it was more like on-premise or maybe more on the EC2 deployment on AWS. And what has happened is because it was really a legacy product, the whole development team was all long gone. And we had some minimal documentation. Of course, we had certain documentation for this project. And the real information, what we got from certain subject matter expert still there. Like the scaling was the big issue during the live matches. So in a sense, it was always stuck in one particular scaling factor where it could not be bring it down when matches are not going. And if matches are getting increased number of more matches, it could not able to scale that much. So scaling was the big issue. So these were the legacy system problems we got with this project. So the challenge was to modernize this completely while maintaining all the functionality. That was the challenge given to us, and the timeline was pretty aggressive. And what we could able to deliver with the AI system tool and this whole implementations, we could able to implement the front end and in React and Next.js, uh, pretty fast front end, converting all JSP pages into the React with Next.js 14, and then backend like a Node.js. If you look at, I have actually put it at from and to. You can see two tech stack typically. On the top, if you see here, it is like Node.js Express. Even we have implemented Fast API, Python based implementation, and all with the AI assistance tool and the Postgres SQL um, as a modern database. And throughout, we have used a TypeScript to catch the problems before even production and use database like Postgres with the Prisma ORM, um, and then implemented the real-time WebSocket for live scoring. And some of the infrastructure implementation like Terraform and Docker containers, even to have system tested on a local Docker container and then take it uh, to a production cloud. Those kind of implementation we could able to do pretty quickly. And then while implementing all these modules, testing, comprehensive end-to-end testing, use cases with Playwright, we could able to do pretty quickly. And if you look at the right-hand side, those cards, those were the results. Basically, we could able to do all of this in 4 weeks as a MVP, which typically in traditional development method would have taken at least 15 weeks. Um, and within 4 weeks, we could able to initially do uh, uh, whole implementation. Um, yeah, so if you look at the 4 weeks of delivery with MVP, 60% cost reduction. So what does mean by 60% cost reduction? Because we could able to do with a very small team, with just 2 developers, um, with when traditionally would have um, taken 4 to 6 developers to do without modernization techniques, what I've talked about here, and tools, and very fast delivery of modules. There was less work because AI generated test cases catching the issues actually quite early in the code. and then 40% infrastructure saving because we could able to implement serverless architecture altogether, getting away from EC2 just consuming so much of deployment and hogging so much of cost on AWS. So we could able to do lambdas, serverless, Fargate based approach conversion in the architecture, and that typically makes it serverless architecture, which means you can do one match to 10 matches, uh, almost like a pay for what you use, right? That kind of model on AWS infrastructure. So during the non-match, the cost was minimal because serverless components not running because there was no load, and the scaling, auto scaling was in place. And during the live matches, the thousands of concurrent users, if they are coming in, it could able to scale automatically. Right. So this is all about the presentation. I've come to end. Now we are ready to, yeah. So any of this, if resonates you, if you're like legacy systems, if you are able, you are curious about, one moment, I'm just getting ping. Um, Curious about what AI assisted modernization could do for your organization, we can talk about that. We basically offer a free assessment here, no commitment and obligation. We will work at your system, understand your challenges, and give you an honest assessment of what modernization could look like for you. You can reach out to us and our contact at hexacorp.com or go through our website and reach out to us. So even if you're not ready to start a project tomorrow, I'm happy to be your sounding board. Uh, I can act like a sounding board. Sometimes just having an outside perspective of your challenges can be valuable. Thank you. Uh, it was a pleasure sharing thoughts and knowledge with you today. We can open up for questions here. Um, um, Revati.
Okay. Thank you. Thank you, Manish. That was a wonderful session. So thank you everyone for attending today's webinar. Your questions will be answered via email, just like told before. So if you have additional queries, write us to info@hexacorp.com. To know more about Hexacorp, please visit www.hexacorp.com. Once again, thank you all for your time. Thank you, Manish, once again for being
Thank
here.
you.
Have a great day ahead. Stay tuned for our next webinar. Thank you.